Welcome, everyone. You've tuned in for your daily briefing on crucial current affairs. This is the Deep Dive for April 21st, 2025, Part 1. We've tailored this specifically to give you that edge for your UPSC preparation.
That's right. Our mission today, as always, is pretty straightforward. We're here to dissect the most recent, most relevant information, really pull out those key insights.
And, some topics might ring a bell. We might have touched on them before, so think of it as a useful bit of revision, too, reinforcing that understanding.
Absolutely. And we've got quite a range today. Everything from potential ocean worlds out in space,
right through to major infrastructure projects here in India, and even some health initiatives, so quite diverse.
Definitely. Shall we jump in?
Let's do it. Where are we starting?
Let's start light years away, actually, with exoplanet K2-18b. This one's generating quite a buzz in astrophysics.
Oh, yes, K2-18b. We've discussed exoplanets before. What's the latest here? It's the one in Leo, right? 124 light years away.
It's exactly. Discovered back in 2015 by Kepler. What makes it fascinating, especially for the habitability question, is its size. It's big.
How big are we talking?
Well, it's about 5.2 times wider than Earth, maybe 9 times more massive, so likely a hydrogen-rich atmosphere. And it gets similar sunlight to Earth, interestingly.
Okay, similar radiation. That hints at habitable conditions, potentially. And the atmosphere, that's where the big news is, isn't it?
That's right. Hubble saw water vapor back in 2019, but the recent James Webb data that's shown carbon dioxide, CO, and methane, CH.
Right, and the key finding wasn't just what is there, but what isn't.
Precisely. In a hydrogen-rich atmosphere like that, you'd expect ammonia. Yeah. But it seems to be absent, alongside the CO and methane.
And the significance of that is?
Well, it strongly points towards the possibility, a potential liquid water ocean sitting beneath that atmosphere.
Wow. An actual ocean? Incredible. And wasn't there something else detected? A potential biosignature?
Yes, another layer of intrigue. Indications of either dimethyl sulfide DMS or maybe dimethyl disulfide DMDS.
DMS. Now, for UPSC aspirants, why is that significant? I recall it being linked to life on Earth.
Exactly. On Earth, DMS is overwhelmingly produced by marine life, particularly phytoplankton. It's part of their life cycle, decomposition.
And didn't a study find bacteria can produce it too? Soil bacteria.
Good point. Yes, a 2015 study highlighted that. Some soil bacteria have the genes for it. So finding DMS or something like it on K2-18b isn't proof of life, not definitively.
But it's a strong hint, a biomarker.
A very compelling potential biomarker, yes. It suggests biological processes could be happening in that potential ocean. It really expands our thinking about where life might exist.
Fascinating stuff. Okay, let's bring it back to Earth and closer to home. Medical biotechnology, specifically Parkinson's disease. There's news from Kyoto University.
Yes, a phase 3 clinical trial. It's quite significant. They're using dopaminergic progenitors derived from human-induced pluripotent stem cells, iPSCs.
Right. Let's break that down. Parkinson's involves the loss of dopamine-producing neurons, affecting motor control.
Exactly. It's neurodegenerative. Dopamine is crucial for movement. And current treatments, well, they mostly manage symptoms. They boost dopamine levels, but they don't replace the lost neurons.
Okay, so they're palliative, essentially. How do these iPSCs offer something different? What are they?
Right. So iPSCs, basically, scientists take adult cells, like skin cells, and reprogram them. Turn back the clock,
Back to an embryonic-like state.
Pretty much. Making them pluripotent. Meaning they can then develop into any type of human cell, including those dopamine neurons lost in Parkinson's.
So the potential is actual restoration, not just symptom management.
That's the potential, yes. And iPSCs aren't just for Parkinson's. They're being looked at for diabetes, leukemia, other neurological issues.
Yeah.
Plus, they're great tools for drug testing and just understanding diseases.
Okay. And just to clarify the basics on stem cells, generally they're undifferentiated, they can renew themselves and become specialized.
Correct. Think of bone marrow, the gut lining. They have active stem cell populations for repair. Other organs have them too, but maybe less active.
And there's the distinction between embryonic and adult stem cells we should probably touch on.
Definitely. Embryonic stem cells, or ESCs, they're pluripotent, like iPSCs, derived from embryos. Easier to grow in labs, but there are ethical debates, obviously.
Right, and adult stem cells.
Those are usually multipotent. They can become a few cell types, but generally limited to their tissue of origin, found in mature tissues. Harder to isolate and grow, but fewer ethical hurdles.
Got it. So understanding these biotech advancements, especially for conditions like Parkinson's, is really key for the science and tech part of the UPSC syllabus.
Absolutely vital.
Okay, from the cellular level, let's zoom way out. Geologically speaking, a hidden landmass under the Davis Strait, a proto-microcontinent.
That's the one. The Davis Strait proto-microcontinent. A pretty exciting geological find, actually. It's tied to the whole tectonic story of the Davis Strait.
The area between Baffin Island and Greenland.
Exactly. Millions of years ago, the tectonic plates were shifting around up there, and this process basically formed this chunk of, well, thicker continental crust on the seabed.
How thick are we talking?
Around 19 to 24 kilometers thick, this proto-microcontinent bit. And it's surrounded by slightly thinner continental crust, separating it from Greenland and Baffin Island proper.
Okay, and just a quick refresher on the Davis Strait itself, geographically.
Sure. It's that wide stretch of water in the North Atlantic, connects Baffin Bay up north with the Labrador Sea down south, separates Canada's Baffin Island from Greenland.
And it's part of the Northwest Passage route, right?
Yeah, it is, a key part. It's a very broad strait, maybe 200 to 400 miles wide. And geologically, it's complex. Underwater basins, ridges, formed by something called strike-slip faulting.
Strike-slip, where the plates slide past each other horizontally.
That's it. Along the Ungava Fault Zone around 45 to 62 million years ago, those movements helped form the Labrador Sea, Baffin Bay, and eventually the Strait and this submerged microcontinent.
So another reminder of how dynamic our planet's geology is. Important for understanding physical geography for the exams.
Definitely. Plate tectonics in action, even hidden beneath the waves.
Okay, let's move from discoveries under the sea to engineering marvels on land. The Pir Panjal Railway Tunnel.
Ah, yes. Part of the bigger Udhampur-Srinagar-Baramulla rail link, the USBRL project. A huge deal for connectivity in Jammu and Kashmir.
And the Pir Panjal Tunnel itself, India's longest?
India's longest transportation railway tunnel, yes.
Yeah.
11.2 kilometers long, also called the Banihal Railway Tunnel.
And it connects Quazigund in the Kashmir Valley with Banihal in Jammu.
Under the mountains.
Under the Pir Panjal Range, exactly. And importantly, it's the only broad-gauge mountain railway tunnel currently in India.
The Pir Panjal Range itself is pretty significant geographically, too, isn't it? Part of the Lesser Himalayas.
Very significant. Stretches across Himachal Pradesh and J&K. Got major peaks like Indrasan, Deotiba. Hydrologically important, too, separates river systems, source for tributaries.
And historically, passes like the Mughal Road route.
Right. The Pir Panjal Pass for the Mughal Road and the Jawahar Tunnel, the road tunnel, goes under the Banihal Pass in the same range. Plus, tourism hotspots like Gulmarg are there. So this rail tunnel is a game changer for year-round connectivity, bypassing the snow issues with the Jawahar Tunnel.
Absolutely. Ensures connectivity regardless of weather, cuts down travel time significantly. Crucial for the region. Understanding these major infra projects, especially in strategic areas, is key UPSC territory.
Agreed. Now, let's mark an important anniversary. 50 years since the launch of Aryabhata, India's first satellite.
A truly foundational moment. April 19th, 1975.
Yeah.
Named after the great ancient Indian mathematician astronomer, of course.
Launched from the Soviet Union, Kapustin Yar, with their help.
Yes, a collaboration. But it was indigenously built by ISRO. It put India into a very exclusive club back then, only the 11th nation with satellite capability.
And its mission was scientific. Solar physics, X-ray astronomy.
That was the plan. There was an early power failure, unfortunately, which cut the experiments short after about 5 days.
Right. But it still managed some observations.
It did. Got some initial X-ray data, and importantly, the satellite itself kept transmitting data, proving the system's work. It actually stayed in orbit for almost 17 years.
Wow, nearly 17 years. Re-entered in 92, and the name Aryabhata Prime Minister Indira Gandhi chose it.
She did indeed. A nice touch connecting modern science with ancient heritage. Both India and the USSR issued commemorative stamps, too.
Yeah, it really signifies India's early space ambitions, the importance of collaboration, and that link to our scientific past. Definitely something to remember for modern history and S&T sections.
Without a doubt. A landmark.
Okay, from pioneering space missions to current maritime presence, INS Sunina's deployment.
Yes, INS Sunina, one of our Seru-class offshore patrol vessels, or OPVs. It's currently deployed to Africa, recently reaching Nacala Port in Mozambique.
And this is part of the iOS Sagar initiative.
Correct. Indian Ocean Ship Sagar. It's an initiative designed to bring together navies and maritime agencies from the Southwest Indian Ocean region. Sunina's deployment includes providing training to personnel from friendly foreign nations.
And Sunina itself indigenous, built by Goa Shipyard.
That's right. Commissioned in 2013, based under Southern Naval Command. It's a testament to our domestic shipbuilding capability.
What are its main roles? Patrolling, surveillance?
All of that.
Right.
Fleet support, coastal and offshore patrol, ocean surveillance, monitoring sea lanes and offshore assets, even escort duties. It's quite versatile.
Capabilities, speed, armament.
Pretty capable.
Okay.
Powered by diesel engines, can do over 25 knots, has good automation, advanced navigation, and communication systems, armed with a 76mm gun, close-in weapon systems, chaff launchers, and it can carry a helicopter.
Right, extends its reach. And the bigger picture here is the Sagar Initiative, security and growth for all in the region.
Exactly. This deployment directly reflects that policy. India positioning itself as a, quote, preferred security partner and first responder in the Indian Ocean's region. The tagline sums it up. One ocean, one mission.
Important for understanding India's maritime strategy, naval power projection, and regional role. Key for IR and security topics.
Absolutely.
Now let's talk public health, a new initiative called HEALED.
Yes, HEALED. Healthy Liver Education and Alcohol-Associated Liver Disease Prevention. It was just unveiled by the Union Home Minister.
A national initiative focused on liver disease, launched by ILBS.
Correct. The Institute of Liver and Biliary Sciences is spearheading it, and it's being called a first-of-its-kind national effort.
What's the approach? Is it just treatment?
No, it's much broader, multi-sectoral. It combines public education, very important, early screening, and then psychological and medical treatment for alcohol use disorder, alongside general liver care.
So prevention, awareness, treatment, rehabilitation, the whole spectrum.
Precisely.
Sure.
Tackling it holistically. A big part is also reducing the stigma around alcohol dependence through mental health support, community outreach, and pushing for policy reforms.
That's crucial. And there was a guiding principle mentioned.
Yes, quite poignant. Behind every failed liver lies a missed opportunity. Really emphasizes the need for early action and prevention.
And ILBS, the institute behind it based in Delhi. Super specialty hospital.
Yes, in Vasankunj, New Delhi. Established in 2009, an autonomous institute focused specifically on liver and biliary diseases with a dedicated research wing.
Okay, so another important government health initiative to track, especially concerning non-communicable diseases and specialized institutions, relevant for social issues and governance papers.
Definitely.
All right, let's shift to energy. India's prototype fast breeder reactor, the PFBR, commissioning is expected soon.
Looks like next year is likely. This is a really big step. The PFBR in Kalpakkam, Tamil Nadu, marks the beginning of Stage 2 of India's three-stage nuclear program.
Right, Stage 2. And this PFBR, it's the 500 milliwi one, developed by BH Avini.
That's the one. BH Avini was set up specifically back in 2003 under the Department of Atomic Energy to develop this fast breeder tech. Construction started in 2004, faced some delays, but it's nearing completion now.
And what makes it fast and a breeder? How's it different from our current reactors?
Okay, two key things. Fast refers to the neutrons. Unlike current PHWRs that use slow or thermal neutrons, the PFBR uses fast neutrons. And instead of water, it uses liquid sodium as a coolant.
Sodium coolant allows higher temperatures, more efficiency.
Exactly. And the breeder part is critical. It's designed to produce more fissile material fuel than it consumes. That's key for sustainability and using our resources effectively.
So it breeds fuel. What fuel does it use initially?
It uses a mixed oxide fuel, MOX, containing plutonium and uranium. This allows for high efficiency. And the sodium cooling, while efficient, also requires very advanced safety systems, which are built-in strong containment, passive cooling mechanisms, and so on.
And this fits into the grand plan, the three-stage program. Could you quickly recap that?
Sure. Stage 1 is primarily our pressurized heavy water reactors using natural uranium, plus some light water reactors. Stage 2, which the PFBR kicks off, involves using plutonium recovered from Stage 1's spent fuel in these fast breeder reactors. These FBRs can also convert thorium into uranium-233.
Ah, and thorium is the goal for Stage 3.
Precisely. Stage 3 aims to use thorium-based fuels, mainly that uranium-233 bred in Stage 2, and advanced heavy water reactors or similar designs. It's all geared towards long-term energy security using our abundant thorium reserves.
Got it. So the PFBR commissioning is a crucial link towards that goal. Essential knowledge for energy security and S&T.
Absolutely critical.
Okay, let's delve into some fundamental biology now. Enzymes and coenzymes. Seems basic, but always relevant.
Very much so. And timely, too, given things like that recent Nature highlight on gene-edited biofortified rice. Shows how understanding these basics translates into real-world applications, like improving crop nutrition.
Right. So enzymes, protein catalysts, speeding up reactions in our cells,
Yeah.
essential for metabolism.
Exactly. They're the workhorses.
Mm.
And many need helpers cofactors. If that helper is an organic molecule, we call it a coenzyme. They bind to the enzyme, help it do its job in various metabolic pathways.
And one specific coenzyme that often comes up is coenzyme Q, or ubiquinone.
Yes, CoQ. It's an organic antioxidant, has this structure with multiple isoprene units, comes in different forms, CoQ1 through CoQ10. It's lipid-soluble, lives in cell membranes, and it's absolutely vital for mitochondria.
The cell's powerhouses for energy production.
That's its main job, key player in the electron transport chain where most cellular energy, ATP, is made. It's everywhere, in every cell membrane.
Interesting. And there are different forms in plants versus humans.
Generally, yes. Plants, especially cereal crops like wheat, rice, barley, corn, they predominantly make CoQ9 with 9 isoprene units. Humans primarily use CoQ10.
CoQ10, why is that one so important for us?
Well, same reason essential for that mitochondrial energy production. Organs needing lots of energy, like the heart, brain, liver, kidneys, have very high levels. While our body makes some, and we get some CoQ9 from plants, we often need additional CoQ10 due to factors like aging or certain health conditions impacting its production or utilization.
So understanding these basic biochemical players is fundamental for biology, health, nutrition, even agriculture topics in the syllabus.
Absolutely, foundation knowledge.
Okay, finally, let's look at another major project, this time hydropower, the Lower Subansiri Hydroelectric Project. There are concerns downstream.
Yes, NHPC, the National Hydropower Corporation, is moving to start generation at the 2,000-megawatt Lower Subansiri project, or LSHP. But it's causing worry in downstream Assam about potential impacts.
Where is it located exactly? It's on the Subansiri River.
Right, on the Subansiri, which is a major tributary of the Brahmaputra. The project site straddles the border between Arunachal Pradesh and Assam, and it's huge, set to be India's single largest hydro plant once finished.
2,000 milliW. That is massive. It's a run-of-the-river type.
Yes, run-of-the-river design, developed by NHPC.
Can you give us a sense of the scale? The dam, tunnels.
Sure. It involves a big concrete gravity dam, 116 meters high from the riverbed, creates a reservoir holding about 1.37 cubic kilometers of water. The powerhouse has 8 big turbines, 250 milliamp each,
And getting water to them.
through 8 large headrace tunnels, then surge tunnels, then penstocks leading to the turbines. Finally, a wide tailrace channel returns the water to the river.
So the concerns in Assam are about water flow changes, sediment.
Primarily, yes. Concerns about how the dam's operation will alter the river's natural flow patterns downstream and how it might affect the transport of sediment, which is crucial for agriculture and the river ecosystem in Assam.
Right. Another example of the complexities of large infrastructure projects balancing development needs with environmental and interstate concerns, crucial for geography, environment, and even governance papers.
Exactly. These are multifaceted issues.
Well, that brings us towards the end of this deep dive. And quite a journey it's been.
It really has. From potential oceans light years away with K2-18b,
To stem cell hopes for Parkinson's, discovering hidden geology under the Davis Strait.
engineering feats like the Pir Panjal Tunnel, celebrating Aryadsa's legacy.
India's maritime reach with INS Sunaina, the HEALED initiative for liver health.
Progress on the PFBR for nuclear energy, the basics of enzymes like CoQ.
And finishing with the complexities of the Lower Subansiri project. All current as of April 21st, 2025, Part 1.
And all, hopefully, very useful for your UPSC preparation.
Absolutely. It's quite something to see the connections, isn't it? How science, technology, infrastructure, health, and geopolitics all intertwine.
Definitely food for thought.
Which brings us to our final question for you, our listeners. Considering this rapid pace of development we've discussed, how do you see these individual pieces shaping India's future in the coming years? Think about technology, geopolitics, the environment. How does it all fit together?
A great question to ponder.
Indeed. To make sure you catch our future deep dives covering critical developments like these, please do hit that like button and subscribe to the channel.
Your support keeps us going. Thanks for tuning in.
We'll be back soon with Part 2.